Hey everyone, I'm Danny. I'm a PMC member on Beam, and Ken, you want to go ahead?
Yeah, I'm Ken. I'm the PMC chair of Beam. There we go.
And today, we're talking about Beam 3.0 and beyond, so kind of predicting a possible future for Beam.
Yeah, I guess I'm starting. Okay, we'll pass this thing back and forth. Now I see it has arrows on it. That's how it works. Okay, so I'm just going to first start off by saying that Beam's code base now is 10 years old. I've kind of been working on it most of that time. And the core is stable, it's mature, it's been proven in all sorts of contexts. And my thesis, and we can all have our own theses, but mine is that we've sort of entered an era of more building on top of the core than sort of continuing to fiddle with it. Although we're still doing a few things. So I'm going to really quickly run through what I mean by that, just to sort of set the context to make the rest of what we say make sense. So these are the things that are stable and underlie Beam, and not just Beam, but most big data processing shares most of the same foundations. So to start with, Beam is the successor to MapReduce, or it's a descendant of MapReduce, right? That's where we sort of applied functional programming, and it inspired the entire generation of big data systems after it. Google researchers continue to work on this, and with Flume Java, they improved on that by figuring out that you could have a whole graph of maps and reduces, and you could optimize it so that you're, say, this is my attempt to illustrate fusing a bunch of maps together. So you run it on one box and doing things like combiner lifting to minimize how much data is shuffled. Now pretty much every system out there does the same thing, right? So this is a foundational approach to big data. Beam didn't just optimize existing primitives. Beam sort of worked on introducing new ones when you realize that we actually need a little bit more expressivity. So this is the diagram we use to talk about per key stateful workflows. And this has been mimicked in Flink, and I've seen it in a couple other little mini languages that people make. So this, regardless of how the diagram looks, is sort of like a fundamental primitive that is all over the place now. Something we don't talk about enough is Beam's dynamic splitting and work stealing, which is still awesome. And so what we have here on the left is sort of a diagram of your typical, you split the data and then you process it. And this is what a lot of people do, what the original MapReduce did. And I mean, God forbid your data is just pre-partitioned and you can't split it. But if you have Beam's dynamic splitting, it can be a little difficult to use, but you end up with the diagram on the right, where you can steal the work, you can redistribute it, and you get much better runtimes. So Beam, obviously, we advocate that batch and streaming should be unified. You kind of, if you're running a streaming application, you need to be able to do backfill when you have a bug. You need to run experiments. And if you're running a batch application, and you want to have greater control over sort of the trade-off between latency, you want to be using the same code for both. And this is really just a necessary aspect of stream processing. In streaming, we talk a lot about how event time and processing time, they need to be made independent. And when Beam sort of laid this out and this advocacy, this is just sort of generally accepted now. You can't really have correct time series processing if you don't treat the timestamps on your time series as derived from the data, as opposed to just when you happen to be processing them. We incorporated this into SQL. We worked with people from Flink and Calcite and Oak Ridge National Lab, and we published a paper about sort of how we thought this could fit into standard SQL. It'll probably end up being a little bit different in the standard if and when that comes about, but the concepts are more or less going to be the same. It's just sort of a way of expressing how you can do aggregations over infinite data sets that have timestamps on them and still have a meaningful result. But so, what I'm going to say about this, anyhow, I wasn't going to say much about it anyhow, except to say that at this point, we have this protocol where we can take Go, we can take Python, we can take Java, SQL, we can take any language can sort of be expressed and then run on any data processing engine. And engines come and go, and they all have new ideas about how you do scaling, checkpointing, and scheduling. But what is stable as part of Beam that at this point it's sort of proven that it's good enough and it really does the job, is our protocols for calling your sort of business logic code from the runner, right? We know that it's stable and high performance. But anyhow, the sort of the proof is here. It's all of you here and all these logo slide, which is just to say that Beam is already used in a million contexts, right? So that's sort of the last thing I want to say about how the foundation is robust. And the innovation is just now out there and we can rely on it. And then pass it to Danny.
So now I'm going to talk about kind of some of the challenges in front of us. So to Kenn's point, I think we've built a really solid foundation here. But there are still kind of continuous challenges that come up and people ask about. And I'm going to focus on 3. So the first one is basically, how do I even write my data processing? We want to figure out ways to kind of lower the bar for this. It can be challenging for people who don't have a background in code or who don't have a background with Beam specifically to get started. The second thing here is, once I've written this, how do I maintain this? Obviously, we all know that writing the code is not the entire journey. It's just kind of a small part at the start. And it can be challenging to do things like manage my dependencies, update my pipeline over time. And Beam has primitives built in for this, but I think there's room to grow here. And then the last question is kind of the question that everybody has in this moment, which is, how do I AI, ML, LLM, insert buzzword here? How do I take kind of this really transformative set of technology and incorporate it into what I'm doing in my pipelines? So that brings us to Beam 3.0 and kind of, again, one possible vision for our future here with Beam. And this is based off of some of these questions we've seen and generally the kind of broader sentiment around the community. So I'll hand it back to Kenn for the first pillar here.
All right. Okay, so yeah, pillar number 1 is to address this problem of like, how do you write your data processing, right? And throughout Beam's history, we've sort of focused on making it easier to use the thing that we've already got and just sort of incremental improvements. But I think going forward, and we're already moving into this phase, like pillar number 1 is access for everybody, right? We have not just programmers, not just distributed system experts. Just make it easier for everybody to author data processing pipelines. So first step that is you have to have access to your data. For most of Beam's history, there's sort of been this focus on really high performance, high scale, I would say like scale proof connectors for other systems that are intended for big data uses, and that'll continue, right? And right now, like Kamal mentioned, like Iceberg is super hot. Our Iceberg connector is developing really rapidly. You may have seen a talk on that at this summit. And another one that is still continuously improving, even though it's like fairly mature, is our Kafka connector. Like these are both like huge technologies. But a future direction is also to increase the number of IOs, right? Like this is my logo slide for connectors, and there's probably a couple more, but there's not like 500. But there should be really, because there's a million little systems that they're not ready for like data flow to hammer it with requests. That'll just knock over the storage system. But we do need to get that data out of there. And so to make that easier, just sort of building easy ways to just connect to an arbitrary data source. And so like request response IO, you may have seen a talk about how you can use that to make an IO quicker for like a sort of a simpler IO for a lower scale system, especially. Another thing that has sort of been a hallmark of Beam's history is that we shipped complex IOs as like, we would build these things and we didn't expect users to be able to write them. Like we'd write this transform, but then after that, everything else was like your logic. Like you figure out how to use Beam's primitives to like do your thing. But I think at this point, like instead of that, like there's this move towards what we've been calling turnkey transforms, especially pioneered in like the ML space with ML transform and run inference, where in the same way that IOs package up a ton of complexity and best practices, now we have these transforms that address specific use cases and verticals that are sort of prepackaged. You just configure them, and then you're able to get the job done. And so instead of being like we teach you the primitives and now you have a new way of expressing yourself, we just like give you the solution, and as long as you can express it in the language that makes sense for your business case, you can do it. Another thing that's like really democratizing is Beam YAML, and I think it exists and there's like a lot of space to grow here, but here I've drawn sort of the learning curve for Beam, which is that if someone else has written a pipeline, you can invoke it, and we kind of have systems of templates where you provide the parameters, and then you can do it, right? And that's very low barrier to entry. But then if you want something else, you kind of have to like learn to program, learn Beam. I mean, I assume not everybody wants to do that, and even if you like are an experienced programmer, it's not easy to use Beam. Not always. I shouldn't say that here. No, but right. So Beam YAML is trying to sort of like make the learning curve a little bit gentler, right? It both makes it so that there's some accessibility. You don't have, even if you're a programmer, you don't like have to set up a programming environment that's appropriate for your pipeline, so it makes it easier to get started. If somebody else has written sort of a Beam YAML pipeline, it's much easier to take it and modify it. So in addition to Beam YAML that exists today, I see in the future of Beam like a bunch of sort of expanding what it can use, because I think a lot of it, there's more and more transforms to be made into turnkey transforms that can be really easily inserted into a Beam YAML pipeline. And then there's tools built on top of it, right? Like Dataflow has this job builder tool that's a graphical editor for your pipeline, and you can sort of load Beam YAML pipelines into it, and you can save them. And in some ways, it's a Beam YAML editor, but also a graphical editor. And so it's like this perfect interplay of different easier to use tools for authoring your data processing. Okay, this is another aspect of like Beam historically, and it comes from this place, and there have actually been multiple talks at this summit that actually need the origins of like, you control serialization because that's a huge part of your cost, and so you want to like really minimize the amount of data you serialize. But this view that all the data flowing through your pipeline is custom serialized bytes, and like you are highly optimized for that, and it's your own custom sort of way of thinking about your data. It's kind of premature optimization in my view for a lot, and in terms of like making it more accessible for everybody, most data is actually structured. Like, even though you think of like, well, once it's structured, maybe I do SQL. I don't really think that's true. I think it's that like you can, but in general, like, data is structured. Sometimes that structure is too much overhead, and you want to go back to basics and be like, I'm going to encode it my own way. But not generally. And so a big sort of thing that makes Beam more accessible is a move towards like making transforms that just consume and produce structured data. It's easier to debug. They plug together more easily. It unlocks SQL. Let's see, I have some other. Yeah, it also sort of opens up opportunities for optimization and taking advantage of new technologies like Arrow when they come along. And the last one related to that, I'll actually be really quick about this, but it's like a more like new direction, which is to say like once you have structured data, the truth is a lot of what people are doing with Beam is just like shipping change logs from like one database to another. There's like a bunch of that happening. And we were mostly created with like sort of an insert-only view, which makes it so that the moment you actually need to do processing on these changelog records, you are back to not being able to use all the stuff that's already built into Beam. You kind of have to like manage it yourself, because even if your data has a column that says it's an insert or an update or a delete, like none of the stuff that's built into Beam actually understands that and does the right thing. So embedding CDC into the Beam model, and this is where I get bad contradicting my earlier statement, which is like, there is a missing piece of the model here, which is making CDC sort of persistent throughout the whole Beam model, so that when you're shipping stuff from your transactional database into your lakehouse, like all the existing Beam transforms just work. Like, I think that's an important future direction for Beam. Okay, so that's what I have to say about the first pillar. The second issue of, I'm also talking about this one, and then Danny's going to take for the third one, how to maintain a production pipeline. And I struggled for a name for this. We had like Easy Ops and Just Works. I hate Just Works as a name, but that's kind of, there's a couple different aspects to it, so I didn't have a good name for it. But operating your pipeline sort of has like two major sub-pillars, which is that there's the basic thing of just like, you've got to be able to get the metrics, and it should be as smooth and as few hiccups as possible. But then another aspect of it needs to fit into like what infrastructure you already have, right? And that's sort of like your Beam being placed into the context of your infrastructure. I'll talk about a few things that are happening now, and there are presentations at this summit, and also are going to be moving into the future. So managed transforms is a big one. I hope everybody saw that talk. I love managed transforms. So this is sort of, if you're a user, you might think of your pipeline this way. You're like, I'm reading some stuff, do a couple do funds, do group by key, a couple more do funds, right? This is like, nobody actually writes pipelines this simple, right? But when you have a pipeline like that and you deploy it, you think, okay, I got the reading and the do fund, this is all the Beam code that I've written, that's kind of my problem. The runner's gonna manage like the metrics and the scheduling and the scaling, checkpointing, and that's the runner's problem. right? What managed transforms, sort of the thesis is that actually like the reading and the writing is just like, these are these super complex IOs that are built into Beam. And what managed transforms does is it makes it so that the runner can identify them in your pipeline and sort of take ownership of them to move to a world that looks more like this. So you've written the same pipeline, but when you deploy it, you think, okay, the runner's gonna take care of like reading the data, shuffling it, like all I'm thinking about is my do funds. My business logic is the only thing I have to get right. And so like, let's say there's a bug in the Iceberg library and you need, you want to upgrade your Iceberg library, but you're like, oh, I don't really want to upgrade the version of Beam because I'm like 16 versions of Beam behind because it's stable, right? Managed transforms, part of the idea is that the runner has the ability to say like, you're reading from Iceberg, I'm going to manage that. I'm going to like be like automatically upgrading you so that you're actually using the latest version of Iceberg IO and the latest version of the Iceberg library to do that read. Well, it's just not the user's problem anymore. So another aspect of when you're like sort of iterating on your local pipeline here is being able to do your local testing, experimentation and debugging in sort of a more manageable environment and having confidence that when you do deploy it, it's going to work in the way you expect. Now, Beam developed organically where we had like a Java runner and then we had a Python runner. Then we had another Python runner that was sort of able to do some of Beam's like cross-language capability. And it's been a challenge to have a local experience that was really easy to use and reliably represented what was going to happen on deployment. So for very complex use cases, you have to sort of do some of your testing on Cloud Dataflow, for example. And you don't really know like for sure that how it's going to work until you've done that. And so the Prism runner is kind of our answer to that. And going forward, we really will continue to be developing this, I think, because the purpose here is that like if you're just working in Python, you don't actually need the complexity of like a separate runner that was like it's written in Go. You don't have to know that. But like running your Python unit tests on your sort of Python do funds, you still use the existing Python direct runner. But the moment it becomes more complex, where you're like using a Java IO in your Python pipeline, which is totally an ordinary thing to do and like not even necessarily remarkable in Beam, you need something that will reliably represent what's going to happen when you deploy that pipeline. So that's what the Prism runner is for. And I think there's a lot of like further development to go there to make sure that that really is a high fidelity representation of what will happen on deployment. And the very last thing I'm going to talk about, and this is more of an example, there's also talk on this from Stephen, this is sort of the Beam in context notion. This is like when I say talk to a user, they're not usually like, they don't have sort of the blinders that I have where it's like, I'm thinking about a pipeline, right? They've got like 4 or 5 storage systems and message buses, and they're using Beam to write pipelines that connect to them, but often there's like 3 Beam pipelines. So the question is like, when I've got data and I ingest it, let's say over Kafka, go through a Beam pipeline, it writes us to a couple places, there's a couple other pipelines, and you end up putting it in like, some of it goes into data warehouse in one format, some of it goes into Iceberg in another, and then they're like, well, it's kind of too high latency, so like, but like, where is the latency going, right? Or when the data is getting dropped somewhere in the middle, they're like, I think that there's like a problem here where I'm filtering in a way that's not what I want. And so increasingly focusing on the app level instead of like within the pipeline level, I think is an important direction for Beam's future. Boop.
Thanks. So I'm going to talk about the last pillar here, which is responding to kind of the moment here, and that is first-class machine learning support within Beam. You might say, like, we've already got that to some degree, and I think it kind of traverses the existing pieces and our future direction. We do have really excellent model serving support within Beam already, and that's the place I'm going to start here. So we want to enable both real-time and bulk inference workloads, and that includes running things locally, running things remotely, smoothly. One future direction and place we're investing is making it easier to run remote inference in a way that doesn't overwhelm whatever system you're using and allows Beam to provide feedback to the runner so it doesn't outscale whatever you're talking to. But in general, we want to make it really efficient and easy to apply whatever model you want in the middle of your pipeline. So There's, I think, future tech here. There's also just expanding to meet whatever needs arise as there are new frameworks that come up. Like I talked about VLLM yesterday, there's going to be plenty of more frameworks to come. We want to continue to support those well and make sure that Beam can kind of thrive with the new demands of the ecosystem. The next piece of this that I'm going to talk about is feature generation. So again, this is a place where Beam is already extensively used. People use Beam to take input data from various sources and create features. But I think there's, right now, kind of this missing gap of working really, really well with feature stores that are out there. I also think this feeds into some of what Kenn was talking about of providing higher level turnkey transforms. Right now we've got the building blocks, and those are great for building features, but it would be great to have kind of higher level library support. And again, just working really well with the ecosystem. We have our enrichment transform, which allows you to go and enrich data from various sources, and we want to expand support for kind of a variety of feature stores. Similarly, along the enrichment path, we want to make it really easy to enrich with embeddings and just support the whole embedding lifecycle. So embeddings are kind of a core part of working with large language models. I think there's a lot of use cases for using Beam to both generate embeddings that can then be used for semantic search or RAG or other applications. And there's also a lot of potential opportunities for enriching existing data with embeddings from vector DBs. If you want to do bulk queries against LLMs especially to support the RAG process. Right now, Beam has kind of growing embedding transform ecosystem, both with ML Transform, which supports generating embeddings and, again, enrichment. But I think there's, again, just this gap of broader ecosystem support. We want to make it really easy to kind of keep your whole embedding workflow within Beam. So that includes writing to your vector databases, that includes enriching from your vector databases, generating embeddings across multimodal data. Right now, we've got really good text support, and we're working on more support there. I think this is another area that is just kind of rapidly evolving. So a theme here is kind of keeping up with the ecosystem as it moves forward and trying to stay ahead and lead in this space as well. Another space where there's a lot of opportunity is anomaly detection. I think there have been a few talks about anomaly detection or adjacent topics here. But this is an area where Beam can really shine, especially for kind of streaming online use cases. Beam is really well positioned to do this, and we've started to put together primitives here, but I think there's a lot of room for people to come in and collaborate and make this even better. And then the last thing I'll call out is new capabilities. And this slide also got messed up. But the main thing here is there's a lot of parts of the ML ecosystem that Beam is well suited for, but doesn't necessarily touch. And there's parts of the ecosystem that Beam is not well suited for today, but could be in the future. So things like providing higher level transforms for model evaluation, you can already do this really well in Beam. Things like offline training and supporting kind of distributed training, it's something that Beam could do, but we don't have support for it yet because it requires iteration and there's work to be done there. But I think there's opportunity for us to provide this kind of broader ecosystem support eventually, whether that's iterative or online. And then I think like the biggest thing here is that, again, this is just a really fast-moving space. And so we want to be both proactive in leading in the space, but also reactive to whatever cool new technologies come next. To wrap up, so here are kind of the three pillars that we called out. But I've said this is a vision for Beam. And I think that that's a really important thing to call out here is like, this is kind of where Kenn and I think things are going based off of what we've seen from other people and where we think there's opportunity for Beam to grow. But the most important part of Beam 3.0 is going to be the community. And everything here is built on top of you all and the broader community. So kind of the call to action here is get engaged with this. There's a lot of opportunity to shape what this vision looks like. There's a lot of opportunity to add new pillars or contribute to some of these work streams as well. But I think, as with all open source, if you don't have community, you're not going to really have a usable thing. So I'd ask everybody if they have ideas to jump in. So, where will you take Meme 3? Thanks.